Modding DJI FPV goggles with analog input, this time on Hack 5. Hey everyone, Glytch here and welcome back to Hack 5. Today we're going to be talking about modding the DJI FPV goggles I use for flying drones with analog input. But first let's talk about why you might want to do something like this. So DJI goggles, for those of you unfamiliar, are some really cool advanced technology in the FPV world, and a lot of people are adopting it. It allows you to get a digital HD video feed back from the drone, whereas you used to only be able to get analog feeds with lots of static, and they didn't have good signal propagation. Everything that we know from all the other technologies in the past that have gone from analog to digital, you get all those same benefits. So hacking analog input into digital goggles would be taking a step backwards, wouldn't it? Well, not quite. The problem with the technology is it's still in its infancy, and so there are only two what they call air units, transmitters. And they make for a drone that can't get much smaller than this. That little box in there and this camera are custom to this system. The issue with that is they take 7.4 volts minimum. No one's made a single cell LiPo-based transmitter, which also makes for a bigger and heavier drone. And like I said, they're huge. Relatively speaking, if you wanted a small indoor flyer, well, this thing's too wild for that. So with my DIY drone series, where we're trying to build a small, compact, lightweight indoor drone for, people new to the hobby to have a go at, you want to use analog. Odds are, if you're just getting into the hobby, you're going to get a cheaper set of box goggles or something. I don't want to get a cheap set of goggles just for this project because I love the view of my HD goggles. They fit over my glasses. And I don't like carrying excess equipment because, well, I travel a lot, I'm in the van a lot, and equipment takes up space and takes power to maintain. So with the reasons covered why you might want to do this mod, let's talk about how we're going to do it. Now, there are a couple ways of doing this mod. DJI provides an AV-in facility and removable front plate so that you can just run a cable around and plug it in, and you can also tap the power as well. However, it makes for a relatively unclean install, and if those cables get snagged or something, you reach up to scratch your head while you're flying and you pull the cable out, well, you just lost video. So we're actually going to be looking at the kit from iFlight RC. Not sponsored or anything, but it's really cheap. It's like 20 bucks. And that comes with this guy, which is a 3D printed front faceplate, which you could absolutely print yourself. And also the pre-heat shrinked power converter that will power the FPV module. And this is the slightly more expensive part. These go for between 120 and 140, 150, depending on what module you go with. I'm using the TBS Fusion module just because it's a simple one button, just works kind of thing. As far as tools, you will need a soldering kit. And if you don't have a soldering kit, make sure to check out this video. It's up here somewhere. Make sure to check out that video. That's where I went through what is in my portable travel soldering kit, and it will be perfectly suitable for this job. With one exception, if you're using a iFixit bit set or some other small screwdriver bit set, there are some recessed screws that you will not be able to get at, and so you will need a screwdriver kit, precision screwdriver kit. Other than that, you just need the confidence to open up a highly complicated optical system, but it's not that bad. Just watch out for the ribbon cables. So without further ado, let's get started. This is not going to be an all-encompassing teardown video. I know several other drone channels have gone through this process, so there's no need for me to cover it as well. So we will speed right through this part. I should note that this mod will pretty much void your warranty, as there are a couple of screws here, and I believe one down here that have some potting compound in them, and I have to imagine DJI is using that as an indicator as to whether or not the goggles have been opened. However, I've had these goggles open a couple of times, and I'm not really worried about warranty anymore. And this is actually the part we came for. So as you can see, it's held in by 3 screws, one of which is kind of blind. But if you move this eye all the way over, you can actually get at it without having to take the whole goggle assembly off. Now this is the combination power and AVN board. And this is where we're going to be making our connections for the integrated power tap, as well as the video input. So we'll remove these 3 screws, and again, there is a little ribbon cable underneath. So we want to be really cautious and probably use tweezers when we remove this. We can just pop that little ZIF connector off. And there's our board. This is what we need. We're also going to go ahead and pull out our soldering equipment. So you'll need your soldering iron, your tweezers, your solder, and that should be about it. While we wait for the iron to warm up here, part of the reason I'm even making this video is because the iFlight documentation is all right for the teardown. It shows you where all the screws are and everything, which is why we zoomed through that. However, they show you about a 2-second clip of where you need to put the wires. So this is going to be a little more descriptive. This top left pin on the AVN headphone style jack, that is where we're going to add some solder for tinning purposes. And we're going to connect our yellow wire there. That is the video input wire. I'm lacking helping hands, so this is going to be a little more difficult. There we go. And that is the only connection we're going to make to that, which is good because it's made of relatively low temperature plastic. So you want to be extremely careful not to put too much heat into it. Then we're going to put both of our black wires to this ground pin here. And that goes to the front of the barrel jack. Just like that. And now the red wire will go to the back of the barrel jack. That is the positive connection. Again, I'm going to pre-tin this. Grab my red wire. Tweezers might make this a little easier for you if you have helping hands. And there we go. That's all of our soldering connections done on the expensive side of the goggles. And now, before we reassemble everything, we're going to take the battery eliminator circuit or buck converter, whatever you want to call it, and our TBS module. So the great thing about these modules is they are standardized to the Fat Shark ecosystem, and then all the other goggle makers kind of used it. So these pins here on this header are all going to be the same, regardless of if you're using the rapid fire module, the TBS module, generic module, whatever. And so we're going to put the red here on this far left pin. That's our positive. Then 2 pins over, this third pin, we're going to be putting both of our blacks. And then the 4th pin from the right is where our yellow go. That's our video output. Again, we're going to go through and pre-tin all of our connections. Our video goes to 6. Our live goes to 1. And both of our blacks go to 3. This is going to be the tedious one as there's 2 wires to work with here. So now before we start assembling everything, we should reconnect the power board, the button board, and the FPV module and make sure that all of our connections are good and that we're not going to reassemble everything only to have to take it all back apart again. And now we'll grab our LiPo. I did put one screw back in the power board in its proper spot because we're going to be plugging in a high current power source, and I don't want those pins short in anything. The button module, I just left to hang for the moment. Blue lights, that's a good sign. You can see the TBS Fusion logo. Now, I don't have a camera set up on the bench to actually test this. However, if we can get static on our goggles, we'll know that's a good sign. Now, you're not going to be able to see this part, but I'm going to go into settings and click AVN. And you can see it really distorted. But if I bring this up to the camera, you can see static, which means that if we had an analog signal broadcasting, we would actually see that on our goggles, which is really cool. We've just hacked our goggles with analog input. Now I'm going to disconnect the power, reassemble the goggles. And there you have it. That was relatively straightforward. Like I said, you just need to be very wary of the ribbon cables and double check your solder connections. That's really all there is to it. Now in the next video, we're going to be actually looking at designing the frame that is going to carry this analog camera and transmitter that we used for testing, as well as all the other parts that we are going to be using in this DIY drone series. So make sure to stick around. We're going to finish this up here in the next couple of videos and get on to some more fun stuff. Thank you all for watching. I've been Glytch. This has been Hack 5. Glytch out.
Thanks for supporting Hack 5. Find all our shows, community, and pentest products at hack5.org.